welcome. Thank you for having me. This is my third time speaking at Stir Trek, and I'm super excited. I got my start speaking at Stir Trek many years ago, and I'm hoping they scrubbed that from YouTube. We'll see. I've come a long way, though, so I'll just put this up here for a second and let you guys digest that and just see what you think. For those of you who've been doing this for a while, you probably have some opinions. Is it even fun to make fun of JavaScript anymore or not? Are we past that? We're still making fun of JavaScript? Okay. I mean, it's come a long way, and that's the point of today's session. But yeah, thanks for joining me. So I always do these selfie things, and this isn't going to work in a movie theater, but I'm going to try it anyway. Oh, it kind of works. It's actually not that bad. And as you can see, my phone's almost dead because I've been staring at the schedule all day. So, quick show of hands. Who's read this book? 1, 2, 3. Okay, that's about right. It's an old book. I get it. It's fine. So that's what we're gonna update this today, right? So, welcome to JavaScript, the really good parts. So for those of you that haven't read it, this was a pretty big deal for a hot minute back in 2005, 6, 7, somewhere in there. Like JavaScript, that particular version of JavaScript, ES3 at the time, had been around for a while, and there was a lot of quirks. A lot of the things we poke fun JavaScript for came out because of that version. And then this book came out and helped clarify some things, and it opened my eyes and turned me into among other things, JavaScript developer. But let's update it anyway. So let's get rid of the butterfly because flat is still in somehow. So we'll do that. And sorry, Doug, this is mine now. So keep the lawyer away. And then we can't talk about JavaScript without talking about a few of its friends. So we'll just if you're doing a 60-minute presentation in 45 minutes, you probably shouldn't waste time on animations like this. It's worth it, though. If someone laughed, it's worth it. It's worth it. No, we're not doing that, actually. JavaScript gets a lot of crap for the flavor of the week, the library of the week, the framework, whatever. So, no, we're not doing that. We're just talking plain old classic JavaScript here. And we're going to talk about basically, I'm going to go through and talk a lot about my favorite features I actually use in real code. There's a lot out there. It's a big language, a lot of APIs nowadays. But this presentation really focuses on the pieces I know I use and love. And we're going to just look at those. We're going to look at them, make sure everyone understands how they work, some use cases, things like that. So for those of you that don't know me, Bruno, I'm traditionally from Georgia. I actually moved back to Ohio recently, and I'm super excited about that. Because I love the dev scene up here. It turns out when I moved to Georgia, I just kept flying up here anyway to talk. So I was like, you know what? Let's just go back. Yeah, I'm a 20-year-plus veteran for mostly .NET, JavaScript, web app development. I work for a company called Sitecore now. I'm actually a solutions engineer, which is a sales engineer, essentially. So it's been kind of a career pivot for me. So for those of you who have been coding, developing for a while, you might want to do something kind of adjacent to that. Talk to me about it. I can tell you what I think. And yeah, again, I speak at conferences quite a few places around the generally eastern half of the country, but I'm trying to expand out west. And I do this because I like it. So it's a bit of a hobby for me. So it's hiking. I try to fly when I can afford it, and that's actually going pretty well, so I'm happy about that. But first, I'm going to go through and do the classic brief history of JavaScript. It's going to take maybe 5 minutes to go through this, then we'll dive into the good stuff. Just to give a little context into some of the pieces I'll be talking about today. So, in the beginning, there was Mosaic, the first GUI-based web browser, and it was something. It was something else. I wasn't really there for it. I was 9 at the time, so I kind of missed that whole thing. But anyway, 93 Mosaic comes out and really opens up the web as a visual medium. Netscape Navigator with this perfectly 90s logo, by the way. Looking back on it, it's shiny and round and everything. Anyway, gets this logo and eventually becomes Netscape Navigator through some acquisitions. And everyone remembers dial-up, I hope, to make the point. Again, slow animations, we're skipping that one. At the time, this is 94 was when this desire for interactivity on these static document web pages kind of became a thing. The idea was, can we provide some client-side interactivity that lets us do more interesting things for end users. So that's where JavaScript was born, and we all know this story probably, right? Like Brendan Eich developed this thing in about 10 days. And originally, the naming thing was kind of humorous to me. Originally, he wanted to call it Mocha. Why Mocha? Well, there's this Java thing happening at the time that was real popular. Everyone was really into, and it's like it's supposed to be the next big wave. So one thing led to another, and it's he actually wanted to go LiveScript at one point. Like LiveScript makes it a scripting language, live, interactive, whatever. That sounds good. I would have been okay with that, by the way. But that Java thing was still in the background, so the marketing folks sort of won for a hot minute there, and we ended up with JavaScript, which has been only confusing to everybody since 1995. To this day. I know there's some ownership over the copyright of that, and I don't get into it. Anyway, so 96, ECMA gets submitted to ECMA for standardization. 97, that gets approved. We get essentially what becomes ES1, ECMAScript 1 as a standard. And then ECMAScript 2 comes out in 98, and then I remember 98. This is when I started getting into JavaScript development a little bit as a, what was I? About 14. The only thing I remember about this particular era of interactive web pages was the pop-ups, and this was a complete pain in the butt, right? Like this was obnoxious and bad, and it was stupid. So it got pretty ugly. But anyway, 98 is when I started to get involved with JavaScript, and I did it by something via called dynamic HTML. Anyone remember that term or heard of that term before? Dynamic HTML. I'd go to websites like this and I would find the functionality I want and I'd copy a bunch of code and drop it in my web page. I had no idea what it did. No clue. But I did that. Now, we wouldn't do that today, of course. We don't just go off and blindly copy code from a website and make use of it. We certainly wouldn't do that in a big project by any means, right? Like we would never just install blind code and run with it. I don't do that. Anyway, 99, ES3 is released, and this is a big release. We just didn't know it at the time because this is where you got all of your big features, error handling, regex, switch statements, and eventually everything that would become the modernization of the web from about 99 to about 2009. So your Gmails, your jQueries, your browser speed wars, all that was a thing. Skip way ahead. Ignore ES4. Ignore the naming thing there. ES5 comes out in 2009, and this is like the next big leap for JavaScript. This is where we get quite a bit of modernization that we missed for about 10 years. Strict mode, native JSON support, arrays, strings, date updates, all kinds of API things start to happen. A few years later, we get what is essentially the current version of JavaScript that we still use today, and that's ES6. And you already know where this comic is going, so I'll just go ahead and get that out there. I told you, do we still make fun of it or not? I kind of. But this is the version of JavaScript that we still basically use today. And since then, what's happened is this. We've moved to an annual release cadence, and it's been a lot. Some of these updates over the years have been more interesting than others. Some of them have been big, like async and await was kind of a big deal for promises. And some of this is just simple API updates, like string.replaceAll in the middle there. We're actually going to talk about that one. So with that, talk about the good parts. For those of you who have read this book, this is really an update to that book. It kind of leaves off and everything that would have come had this book continued to be published. Nothing in this presentation is super cutting edge. Nothing's like, oh, you're going to learn something. This may not be eye-opening. It might be, but I'm covering the basics in a way that I learned them, in a way that I hope helps everyone here understand kind of the things that have helped me the most. So of that, we'll talk about some of these and a whole bunch of other things. And some of this is more basic than others, right? Like what's one of my favorite features of JavaScript, for example, is just dead simple, first-class functions. The idea that you can take functionality and you can write functionality that can be passed around like a variable, plain and simple. Now, every modern language does this, and this wasn't even new at the time, but this is a pretty fundamental piece of JavaScript, and this is something that we all use probably all the time, so no big deal. Variable scoping, I'm kind of shameful to admit, I've been writing, and I've been using var way past its prime. So basic idea here is that with modern JavaScript, we've kind of got rid of this idea of this var keyword that was around forever because of basically scoping issues, right? Anything that's declared with the var keyword is declared with very confusing scopes. Typically, it's talking global scope. We fixed that with let and const. The idea here being that let restricts the scope of a variable to block scope, so between curly braces, a block. And the const keyword lets us have partially immutable variables. I say partially, and we'll talk about that in a second. So for various reasons, there's no need to really use var anymore, so let's just toss that away and not even think about it. There's very, very, very few places I would use this nowadays. So let and const are going to be a much cleaner way of handling variable declaration. The other thing I'll call out, though, is that hoisting is still a thing. So I'm not going to talk about hoisting as a feature necessarily, but if you know what hoisting is, it's still something you have to consider with let and const variables. And feel free to ask me about that later. The one thing I'll call out about the const keyword, though, is it doesn't make everything immutable. So, like, for example, we have a person object here, and you can still mutate the properties of it. So, like, the person object itself can't be changed, but its properties can be. So this works, okay? This doesn't. You cannot reassign the entire object. That's constant. So, super simple. JSON, we've been using this anyway. I think anyone who's touched JavaScript has dealt with JSON. The reason I like to call it out is because, like, the idea that I can write code and objects and data and represent that as I'm going to say well-structured code, but structured code essentially, and then, in one line have that serialized up in a way that I can stringify it and send it off over a wire, and, on the other side of that, get that back and, turn it right back into the code I need, just that simply. Before ES5, we had to use libraries to do this, and it was kind of a pain in the butt, but nowadays it's much, much simpler. Oh, yeah, and there we are getting some data back out. Template literals, okay. 99% of the time I use these, I'm basically using these to make my strings look prettier. That's it. There are some other uses of this, like tag templates and multi-line strings, of course, but really it's just me avoiding this, right? Like up to this, up to before template literals, we were concatenating strings together, string space plus string plus whatever, and so on and so forth. And it works, but with template literals, using the backtick character and some tokenization there, we can make that look a little bit cleaner in most of our code. So this is about 99% of the use of it. Tag template literals are pretty cool too. I don't use them very often, but it has a good purpose that, again, I'll encourage you to explore. So you can also evaluate expressions in template literals as well. So if you need to execute code, like a little date, a little subtraction here, for example, that works. And just like that. Optional chaining. This one, this is where I added the most new slides for this because I just did. I had a whole bunch of cool things come up here. Optional chaining is the idea that if something doesn't exist in an object, let's say, you can essentially, actually I'll back up. Let's do this example first. So let's get at some properties of this object. So we have a ship. We want to get the ship name. Like a good developer, we're going to do a bunch of null checks, right? We're going to say, hey, is the ship not null? Is the property we need is not, it's not undefined and it's definitely not null. Okay, perfect. Well, then here's the value we want to use. Pretty simple. Except that we have 1, 2, 3, 4, 5, 6, 7, about 7, 8 lines of code there, and there's other ways to shorten that up. But with optional chaining, which is, again, the actual syntax is this question mark and this dot, and I'll show in the period. I'll show you why this confused the crap out of me for the longest time in a minute. But now we can say console.log ship name. We can get the name there. If we want to get the captain's middle name, which, by the way, doesn't exist in that object, with optional chaining, we just get undefined. So the idea here is that with optional chaining, any value that would resolve to it's null or undefined, it just resolves to that. So if something doesn't exist, you're going to get undefined back. So that's what we're seeing right here. Same thing, if the ship.size.dex, which you notice doesn't exist there, that'll give us undefined as well. So that gives us a way to quickly short circuit our code and do something else, basically. This is where I got really confused because I tried to use this and I could not do this syntax for the life of me properly. You can actually do this as well. So you can check to see if a function can be invoked via, that light is still blinking. I just caught it. Anyway, yeah, does this function exist? Can I invoke it? Well, same thing with properties. Does this property exist? Can I access it? The syntax for this is kind of weird to me at first. Like for whatever reason, I could not wrap my head around this. It just happens to be that the full token itself, syntax is that question mark and period before you invoke a function, right, with parentheses. That's what the parentheses mean. Invoke this function, essentially. Same with accessing properties. So works really. I don't do this very often, honestly, but it's there and it's handy. I'm going to try to make more use of it for some of my code safety reasons. So a complete example then is that, like, let's take what we did earlier, essentially, and just what might this look like? You might write code that looks something like this, where you inspect to see if the ships.size.deck exist, and then we log out whatever. Or we combine this with nullish coalescing operator, which is the double question mark. And this gives us the ability to basically do quite a bit of work on one line. And for the longest time, JavaScript got, I've been doing this since the late 90s as a kid, and JavaScript got kind of weird there about 2009 for me, and it's like, what's all this new syntax? It turns out this is really super helpful, and it's still 15 years old at this point, 16 years old. So we can now use optional chaining to see if, like, the ship shield status is available, and if not, we will nullish coalesce into something else, in this case, the string online, and that's what we actually get back here. So now we can in one line implicitly check for, or explicitly check to see if something exists, and if it doesn't, we have a smart default value. Great way to clean up code. Arrow function expressions, again, this was something I took way too long to learn, and so if you're unfamiliar with them, hopefully this is a quick moment, but I think these are pretty common nowadays. I mean, most languages have something similar. Being a .NET developer, I'm in C# all the time as well, but making use of kind of their version of this, but arrow function expressions are essentially a short, terse syntax for writing functions. So a regular function has the ceremony of the function keyword, a name, some parameters, and a body. And arrow function expressions just take away some of that ceremony. When we get to the promises slides in a couple of slides here, you'll see that we use these all the time, and it really helps clean up our code and make things quite a bit simpler to parse, as in my brain anyway. We can also assign. This first arrow function expression here is really an example of an anonymous function. There's no name there, so it executes on the fly, essentially. And we can assign that function and give it a name to a variable, right? It's really no different than the first example of writing a function with a complete name, but now we've assigned this, again, as a first-class function into a variable, and then we can invoke it where we need to. And really, this is useful when you just need to provide some quick, brief functionality to something else. Think like a callback function, for example. Hey, I need you to go do something after something else, and I pass you in as a variable to another function. Arrow function expressions really help wrap that up, and you'll see that in the promises example in a moment. In fact, we'll just do that. We'll talk about promises real quick. So this one, I actually spoke last year. Here on promises, it's a big topic for me. My promises talk was actually born from this presentation because it was such a complicated topic that I went off and made a bigger version of it. So for those that might have seen that last year, this is a very, very short version of that. But promises are a big deal in JavaScript. Promises provide the API for writing asynchronous code in a very graceful way. The big problem is that as developers, trying to read that code back, like what's going on? Something's happening here, and it's asynchronous, and then where's the code going next? And it's a whole thing. So I kind of simplify promises down to this. A promise is simply the idea that you're going to go do something. So you're going to execute some code, some logic, right? And that will then either resolve and succeed, or it will fail and be rejected. And that's done asynchronously. That's the important part. Everything that do something block, that code that you write, is going to be done asynchronously. And when it's done, then you can handle the result of that. But it's not going to flow in with the rest of your code. You're going to have to handle that kind of outside the rest of your code's expected flow. And my bigger presentation goes into that in much more detail. Strangely on brand with the promises are guaranteed with the asterisk there. They're guaranteed so long as your code doesn't blow up, right? The guarantee is that a promise will execute and it will resolve or it will reject. It will do one of those two things so long as your code doesn't blow up. It's promised, and it will do that one time. So every promise will be executed once, it will resolve, it will reject. That's the guarantee that the API gives to you. So yeah, like me, I find that it's more, you're probably consuming promises more than you're writing them. If you're using libraries and modern JavaScript APIs, you're probably writing code that looks something like this. Go get some data from some server, and then handle the result of that when it succeeds, or handle the error condition when, catch the error condition and handle that if it fails. So this is what most promise code looks like, one way or another. We call these thenables. So go do something. I'll handle the result when it's done with .then or .catch. And lot goes on there. The magic then comes into what happens under the hood. Like if you write your own promise, what does that actually look like? And the promise API, and this is probably the most complicated slide in the entire presentation, but I'll keep it brief. If you want to do something asynchronously, like a network request or some UI work or something, you just want to have something go off and just be done in the background, kind of. I don't want to confuse that with parallel programming and multi-threaded and all that. It's a whole different thing. But if you want to do something asynchronously, this is what it looks like. New up a promise, pass in a resolve and reject callback. So what's gonna happen when you're done? Kind of. And this code goes off and does something asynchronously. Now, when it's done, we get to determine as developers, we get to determine how to handle the result. Like, did it succeed or did it fail? How do we know? We determine that. So let's go off and do a bunch of work. And if it succeeds, we're going to go ahead and call that resolve method. And if it fails, we're going to call that reject method. And those kind of implicitly map to our thenables. So when we succeed, we call resolve. And control flow goes to our thenable there. And we handle the result. And if it fails, or rejects, we handle the error condition there. So that's the under the hood version of promises. And there's, again, my big presentation goes into much more detail, which it is available out there, by the way, for those that might be interested. The bigger question is, when do you use promises? And it's really, when do you use asynchronous programming? Anywhere you want a responsive UI. There's a whole thing on the browser thread, and being single-threaded and how JavaScript executes in the event loop and all that, and it's a whole thing. But short version is, when you want to execute something in a way that doesn't disrupt your primary UI, there's reasons for that. Network request. Anytime you do a network request, like we'll talk about the fetch API here shortly, that's going to be an asynchronous operation. Any kind of task or event-based work you might do, database type work. And really, if you're using any modern JavaScript API after, like, I'd say 2016, 17, somewhere in there, it's basically all asynchronous APIs at this point. So you'll be using promises, mostly consuming them one way or another. So let's talk real quick then about thenable hell. It's a fun term. I think that's probably the official term at this rate. Have you ever written code like this, where you go off and get some data from a server, and then you handle the response, and you transform that data, and that's an asynchronous operation, so you have to handle the result of that. So there's another thenable there, and you get a result, and you have to set some data, and that's an asynchronous thing. And like, you see where I'm going here? Like, you could really start stacking these things up, and don't get me wrong, there are other ways to handle these thenables and the way they chain together. There are different ways to address this. But at my first pass of writing this type of code, I'm doing this. I'm hitting my tab button quite more than anything else on my keyboard to make this all kind of work and line up. So this is, as a human, this is really awful, because it's like, when I have to parse and read this code, there's so many different points where things might flow for various reasons. Does this reject or resolve? And what happens when it does reject? And what happens when it resolves? So that's where async and await come into play, because they basically provide an alternate syntax for working with promises. And admittedly, this is actually where I started. When I started with promises, I started here and worked backwards, because I wanted to understand how async and await worked in JavaScript more than anything. So let's take that code we just saw and rewrite it with async and await. So we have this process data function, which is asynchronous, and I'll cover that in a minute. But let's go get some data from that server, and you'll notice we have the await keyword there. So what's going to happen here is, when our program control flow gets to this line, it's basically going to stop. It's going to pause. It's going to await for that get data from server to finish. Don't know how long it's going to take. We don't care, but it's going to sit there. When it's done, it's going to assign, when it resolves, I should say, it was going to assign the value that comes back to our response variable. Same thing, we're going to go off and transform that data. It's an asynchronous operation. We have that await keyword. We're just going to pause. We're going to wait for that to finish and come back. Same thing here, set some data. It's awaited, so we're going to just pause and wait for that to come back and do its thing. That doesn't hold up the rest of our program, though. Again, everything inside of this process data function, because I marked it async here, because I marked it async, that is basically telling our interpreter, don't wait for process data. When it pauses, when it goes to a wait for something to happen, for an asynchronous operation, for a promise to resolve, just keep going. Don't wait for me. So we can do everything in this process data here. It's all asynchronous code. We can let it run, do its thing, and when it's done, we'll handle that result. This is a hard topic because I throw a lot out there at once, but the last piece to call out here is that I talked about all these promises resolving and succeeding. So when get data from server resolves, the result goes to response, and then same thing with transform data. We have something succeed, and the value gets assigned to that result variable. If anything rejects, if any of these promises here reject or fail, basically, the control goes to that try catch block. So the concept of the thenables of the .then and the .catch, they're the same concept here, just a different syntax. And the best way to kind of compare these two things is really, I think, this way. Like these two blocks of code on the left and right are doing the exact same thing, but as a developer, if someone has to come back and read my own code 6 months, 6 weeks, 6 hours after I wrote it, I hope the right side makes sense. I hope that's a little easier to understand as a human. So that's really what async and await is getting you, an easier way to work with promises from a syntax perspective. Fetch. This is a fun one up until about the next slide. You'll see, I'm going to make fun of a couple things here before we're done. We're on 52 out of, we're moving a good clip, so we'll make it. Again, 60-minute presentation shoved into 45. I've sped this up a little bit. Fetch is fantastic. So if you're still using jQuery for some reason, okay, I won't make fun of that. jQuery is fine. It's okay. It's still a thing. I'm pretty sure everything in jQuery now would just fall through to the native browser version anyway. That's what they've always done when the browser version's available. When there's a native API, it just falls through to that. So. But if you're using like a jQuery or other library for like doing AJAX calls, network requests, you don't have to anymore. Fetch is a thing now. It's here. It covers things, covers our needs, covers my needs very well. So let's go fetch something from a server. So get some JSON data. And of course, it returns a promise. Like I mentioned, all these newer APIs do. So when that's done, we're going to handle the response, and we're going to do some other work. Just be a smart developer and check to make sure we have the right status. And then we're going to get our content back from that response. And in this case, we're calling a special method here, .json off the response. And then again, that's a promise. So when that's done, we're going to go ahead and get our data and log it. I'll let you stare at that for a quick second. So the key thing to call out is that when you fetch something, you have to basically know what type of data you're getting back. There are some helper methods off that response object to make use of. So .json, .text, .blob, form data, array buffer, and there might even be some others nowadays. I'm not sure. But those 5 are kind of the key ones, right? If you get some JSON back, you can get that natively parsed and ready for you, just like that. So no need to use complicated libraries to handle network requests. Okay, so we have this method called fetch, and we're going to go ahead and use it to post some data now. So that's cool. We could do the same thing, essentially. We use fetch, and with the right parameters, we can have it do a post. So fetch, despite the name, in my mind, the name's a little weird. It's just an API thing, right? Like it's a name. Fetches data, or is it posting data? Anyway, you use fetch to post data. Give it a body, all the parameters and the methods and the mode. It's a documentation thing. I'm not here to bore you with the details. I'm just telling you that this can be done now, and it's super easy. And there I'm calling out the one thing you do need is to provide the method. I would imagine in a clean implementation of this, you're probably including the method anyway, whether it's a get or a post, to make the code super obvious. Same thing, you're going to bring that JSON response back. I admittedly still don't use destructuring as much as I probably should, but that's various reasons for that. Give me an array of numbers, and we can unpack those numbers just like that. That's destructuring in a heartbeat. very, very simple concept in the sense that you can take data from an array and extract those values on the left side of an assignment. So we're declaring A, B, C, and D here as variables from our array. And you can see here, if we were to log this, we'd get all those values back. You can even unpack partially, right? So you can get the first and second variables. The names don't matter, but the position does. So we can get those values back and put those out to our console here. Lots of code uses this nowadays. I mean, if you're a React developer, for example, it's everywhere. I mean, that's technically what if you use hooks in React, lots of destructuring going on there as far as what's coming back from your hook. But a simple example might be something like this. So let's take an email address. That's my email address if you want to sign me up for unnecessary things. Traditionally, we'd split this to an array, and we would grab the left, and we'd grab the right side, and sure, it works, and it's more importantly, it's really obvious what's going on here. Any developer's going to see this and be like, oh, I get it, you're breaking down the email. But with destructuring, it's a one-liner now, right? We split it to get our array, and then we just destructure each chunk of the array out, and we get our two pieces all the same. So it's really just a little bit of, not syntactic sugar per se, but it's easier code to write and look at, I think. Array.map, this one's probably a little long in the tooth nowadays, but it's still a handy thing. The idea is that you can get a copy of an array while operating on each element of the array. So if we take like a bunch of inputs here on the left, we can feed those into a map function that comes back with some result for each element. And that's, again, you're getting a new array on the other side of that. So implementation might look something like this, where we have our four strings in an array, and we just send those into the map function, which is an element, an index, an array. 90% of the time, you're just looking at the element parameter there. But we just implement that example I just showed you. Let's do something. Let's operate on each element of that array, and we get those results. Find, I'm using this one less and less lately, but find is essentially returns the first element in an array that matches some condition. Returns the first element. So there's limitations to that, that in some practical terms, but the idea is that it's kind of similar to that map function where it's iterating over the array, and in this case we're doing some comparison and looking for a equals value here. Array filter is contrasted to find, lets you bring back multiple elements. Same basic idea. Here's some data, and we want to filter out all the locations that equal bridge in this case. So we're going to get two results back, just like that. So it's not returning just one element, it's returning all matching elements. Again, it's an iterative function, so think about array sizes and performance and all that, and whatever, if it's important to you. Classes. Okay, so this is an ES5 thing, right? This has been around for a good long time, but JavaScript does do classes. And each class has a constructor, one constructor. I screwed this up so many times. One constructor function that you get to call to set things up, and then it does all the other class stuff that you'd be used to in almost every other language in the world. You can write functions, you can write private members. You can actually do private members now. You're not having to resort to closures anymore. And you can you can instantiate classes just like you would expect, and you can make use of the methods and functions that you'd expect. So that one I'll leave alone, but yes, JavaScript does in fact have classes. Doing okay on time? We are almost to the end. Modules. Wow, this was a mistake for me to explore a few years ago. Modules are very native now. ECMAScript modules is basically the JavaScript implementation, the native ECMAScript implementation of the module idea. And of course, a module is just a way for you to break up big chunks of code across multiple files. So if you've been in the Node world for as long as it's been around, you've been doing that anyway. So we can write functions, export them from one module, import that module somewhere else, and then boom, make use of our code. So just take lots of code, break it up across files. The real problem with this is that there's a bunch of different module patterns in JavaScript that have been around over the years that predate ECMAScript modules. So we're kind of in a situation where there's a little bit of competing standard to some degree. And I think ECMAScript modules are nowadays much more common anyway. But you'll still see some other patterns out there. So it gets me sometimes. I still don't fully understand generators sometimes. It took me forever to wrap my head around this one. But the idea is that I've been to so many talks where someone's describing generators to me, and I was like, I still don't know what you're talking about. I have no clue what's going on. No idea. This syntax is weird. But the way I describe generators, it's an type of iterable that you can customize, essentially. So the idea here is that, and again, with this very weird syntax, right, of the asterisk right off the function keyword, the idea is that you can iterate over something, and every time this generator function hits that yield statement, the function basically pauses its current, it returns its current state and it pauses right there until it's called again. And that's the key that I for some reason could not get over for the longest time. So when we create this generator and we call our next essentially iteration of it, we get the current value of whatever that variable inside that function is. In this case, x is going to be 1 because we incremented it from 0 to 1. Then we're going to increment it. We call generator, get our next value, and we're going to get whatever would be generated inside that loop at the point that we hit yield. Don't know if that helps or hurts, but that's my explanation for it. So what's going to happen here in this example is we're going to increment that x variable infinitely. Every time we call it, we're going to get the next value. Promises, asynchronous operations in JavaScript, promises are built on generators in the background. So that's a way to handle asynchronous code. So that generators needed to be built first before promises. So I honestly don't implement generators a lot. So if anyone has any really good examples of where they're using them, I welcome a little chat afterwards. Anyway, so finally, a couple more things. This is like its own talk altogether. Like I wish I could just spend a whole hour going over all the APIs, because this is crazy. JavaScript has an API for everything now. Like 15, 20 years ago, I could only dream of having the things that JavaScript has nowadays that essentially let you work much closer to a user, right? Like you can interact with the browser. You do geolocation stuff, which has been around for a while. You can get the battery status of a device. The file API can be useful. Notifications, don't abuse those, please. This is the MD, I looked this up the other day. This is the current list of common JavaScript APIs. It's big. There's an eyedropper API now, so you can select colors on the screen. I don't even, like, if you're going to recreate Photoshop, sure, I guess. But browsers do have a native color picker built in now, so I think some of that's built on APIs like that. But there's a lot of fun stuff. I might put together another talk someday and go through some of these in detail, because this is the type of fun stuff that you can show off and be really interactive with. Even like local font access, like I don't know when I would use that. I have no clue. My last one then is string.replaceAll, and I saved this one for last because for so many years I've been doing this where, hey, I need to replace a couple strings here. What's going to happen when I replace it? It only does the first instance. It's that like, string.replace in JavaScript just replaces the first instance of a value. And anyway, for the longest time we were doing something like this. We were doing a regex as a parameter, and it was kind of a workaround so that we could replace all instances of a string. So like when it comes to naming things, when it comes to naming APIs and functions and methods, like this is a really good example of like self-documenting code. I'm going to replace all, absolutely, and it works just the way we'd expect it. So thank you for finally getting that one in the language. What about browser support, though? I mean, a lot of the features here I've talked about actually have been around for a while. So the good news is that browser support is any version of Chrome released after 2021 generally supports everything you see here. The newer APIs that you saw in a couple slides ago are to be determined. But yeah, again, Edge, any version released after 2021 roughly supports all these kind of common features. I have no idea about Safari, despite being a Mac user. It's so confusing, and I don't want to do it. And I did have someone ask me about this one time, so I had nothing. Like, what is that still? Is anyone still writing against Internet Explorer? No. Thank you. Oh gosh. Okay. What I will pull out then here is if you go to, this should work. So I do have a little companion repo. Don't get me wrong. I know there's like a billion examples of all this stuff on the internet, but if you want a companion repo that basically makes all of this code and these slides interactive in the order I went through them. You can go do this, and you can open up your browser console and play with that there, and then you can, there's the solution you can kind of go through, and it's all very well documented code that lets you play with it and tweak it and kind of understand it and reference back to some of the slides and pieces that I went through today. So I'll leave that, where are we? I'll leave that there. I will leave this there, and thank you.